The water cycle is one of the most crucial systems on our planet. It begins with the evaporation of water from oceans and lakes, which then rises into the atmosphere as clouds. These clouds transport water around the world, and eventually, it falls back to the earth as rain or snow. This water seeps into the ground, replenishes rivers, lakes, and groundwater reservoirs, and ultimately returns to the oceans, restarting the cycle. This process keeps the amount of water on the Earth's surface balanced. But what happens when this natural cycle is disrupted? Oil companies use a method for extracting crude oil that involves pumping fresh water from the Earth's surface into deep oil reservoirs. This water, heavier than oil, pushes the oil upwards, where it can be extracted. It's similar to a vinaigrette. The heavier water sinks and the lighter oil rises. However, this fresh water and salt water, in the case of underwater drilling, pumped into the depths, never returns to the natural surface water cycle. It remains trapped in the closed reservoirs beneath the Earth's crust. Globally, about 95 million barrels of crude oil are extracted every day. This is equivalent to about 15 billion liters of oil every day, which corresponds to around 5.513.325.000 cubic meters of extracted oil over a year. These about 5.5 billion cubic meters of oil will be refilled by approximately 5.5 gigatons of water. Additionally, about 4,400 billion cubic meters of natural gas are extracted yearly, which is equivalent to around 4,400 billion cubic meters or 4.4 gigatons of fresh water per year. If so, the total amount of resources in cubic meters would correspond to the equivalent amount of water annually drained and pushed deep into the ground. This equals around 9,900 billion cubic meters of extracted resources to approximately 9.9 gigatons of water. In total, the daily extraction of oil and gas worldwide potentially corresponds to about the same amount of fresh water which is blown into the energy reservoirs or infiltrates them over time by pressure, adhesion, and osmosis. We simply move the water. And the consequences of this practice could be enormous for the inner cycle of our Earth. Like a break in a chain, less water in soils. With less water in the soils, soil quality declines, impacting agriculture. Less water in rivers and lakes. Rivers and lakes dry up, threatening the habitats of many animals and plants. Fewer clouds and rain. Less water means less evaporation, leading to fewer clouds and less rain. Less water vapor in the air. This water vapor helps cool the atmosphere. Without it, the Earth heats up more. Melting poles. Less water in the atmosphere also means less snowfall and ice formation at the poles. In short, pumping fresh water into the depths significantly disrupts the Earth's water cycle. This has far-reaching impacts on our climate, environment, and lives. This scenario is a plausibility study that considers the physical laws of our planet, where water is always heavier than oil and natural gas, and surface water fills all Earth layers and reservoirs below the groundwater level or sea level. How plausible is this scenario to you? Do you have an alternative explanation or perhaps even evidence that contradicts it?